Okay, sorry we're late, guys. We're live. We're live. Hold up. Okay. All right. Cool. Let's get going. Yo, hello.
Hello.
Oh wait, hold up. Let me turn you up.
Yeah.
I'm not sure. Oh, hello.
Hello. Hello. Yeah, I can
There
hear
we
you.
go. Cool. 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 Yeah. Sorry I'm late.
Yeah, no worries. No worries.
All right. So let's catch up on your practice. How's that going?
So, I have, I don't know, I have lost confidence in myself, but yeah. I did a couple more questions. I did some mocks too. Um,
All right. So where's the confidence lost?
cause there was a really easy question that I thought I knew it, but then I kept testing it and testing. I kept testing it, and then I kept getting more confused, and then testing it. But then when I finally got it, it it clicked, but it was really simple. It was a really simple solution that I should have thought of in the beginning.
Mm-hmm.
This is during a mock interview though, so I don't really have the code for it because after that, I don't know. They just didn't let me see the code again after I submitted it, sort of thing.
Okay. Do you have approximately what the problem was?
Yeah. So approximately the problem was you have like a 2D array.
Mm-hmm.
Well, the array size, the inner arrays were just basically size 3. It was basically came from timestamp, uh, and a number, which is the amount of visitors, and the and the last number is whether they exit or enter the mall. Essentially, what I'm supposed to do is find the busiest time in a mall, and given these timestamps, this 2D array full of timestamps,
Mm-hmm.
the amount of visitors, and whether the amount of visitors exiting or entering, I just have to find the maximum amount of visitors.
Okay. Okay. Slow down. Slow down.
Yeah.
So you're given an array of, well, a 3D array, really. So a
Yeah,
timestamps,
yeah.
visitor, and enter or exit. So it's like a
Yeah.
class that represents that. Okay. And your job is to find the busiest time in the mall. What else?
That's basically it. Return the timestamp that's the busiest time of the mall.
Okay.
Busiest as in most amount of visitors
Sure.
currently.
Okay. So then let's say what was your step by step? Why did you feel like you were struggling? And what made you confused to begin with? Let's start there.
Okay, so the timestamps they give me were in epoch time, right?
Okay.
And then I don't really understand epoch too well. And then the question said, oh, given these times, calculate the busiest time period in the last year, right? And I'm like, last year, I don't even know which ones are this year or uh, the last couple years. So so I got a little bit confused for that until I told the interviewer like, hey, I'm just gonna assume all the timestamps you give me are the previous year because I don't know any APIs to read the epoch time currently,
Mm-hmm.
like translate the epoch time to the actual date because I don't know epoch time too well. So that was a bit of confusion that took me a while to decipher and understand.
Okay.
After that, it was me trying out a lot of test case, and then me getting a little bit confused at the test cases because part of it was me doing the math a little bit wrong and me also disregarding epoch as something I should consider when doing my solution because I didn't really understand epoch too well. So I was like, okay, let's just consider the amount of visitors entering or exiting the mall and then count the maximum amount of visitors. And then record the timestamp that has the most amount of visitors, right?
Wait.
But
Repeat that. I don't understand.
my bad. So I didn't understand epoch time too well, so I disregarded it when thinking about a solution.
Okay.
And so essentially, my solution became, okay, let's think, uh, let's just keep track of the total amount of visitors in a mall. essentially, without regard to the timestamp.
Okay.
So that led me down a path where, okay, I didn't consider the case where the epoch times are all similar in
Mhm.
time, like all the same time,
Mhm.
and then some are different times. So
Mhm.
what I had to do was, okay, if they're different time periods, I mean, only if they're the same time period, I have to just calculate the difference of those. So like pretend that 10 visitors entering at 8 o'clock, there's 8 visitors exiting at 8 o'clock. So I just have to count, okay, just 2 visitors entered at that time.
Okay.
There's only 2 visitors in the mall, so I disregarded that a little bit, and then that made me have to redo my design of the solution again. And then after that, once I did get it, I was able to code it up.
Okay.
But I didn't get the optimal solution either. I just got I got the same time complexity, but not the same space complexity.
Okay.
So that, because I was a little bit panicky at that point.
I noticed what happened here. Basically, what happened was that you didn't think about what can go wrong. It's not that a failure to understand. Let's go step by step. First of all,
Yeah.
the fact that you didn't know Linux epoch time. That is a bit of a red flag for anyone doing programming, because anyone, like, I'll tell you, most people already know when you say Linux epoch time, it's just the seconds from the January 1st, 1970.
Yeah, I know that, but I just didn't know how to like translate that into the actual date of like what year, translate the epoch time into a year, day, and like.
You don't even need to know that. That's the thing.
Oh, okay.
Do you know why?
No.
You only care about the data from the last year, right?
Mm-hmm.
So all you need to do is take the current epoch time minus however many seconds 1 year is.
Yeah. I mean, yeah. I just didn't know like any APIs, like any built-in methods to calculate define the current epoch time.
Okay, well that's fine. You could have just said that, and then it would have been fine. It's like, let me just invent like a system dot get current time millis or whatever.
Okay.
You can literally, if it's something like that is not too terribly core to the problem, in this case, I would argue it's not. Then you can just invent it, and then the interviewer will just give it to you, because he's more or less more interested in your ability to actually solve the problem rather than like whether or not you know the API for this. Like, remember what I've been told you before. It's not about you knowing a whole bunch of programming little tidbits or memorizing answers. It's about being able to have a logical progression through your problem, right? And you just zeroed in on the wrong fucking thing. You thought knowing the Linux API is more important than solving a problem.
Yeah.
That's where your first mistake was. So, next one. So you said math was wrong, disregarded epoch time, and you also didn't think about the timestamp being the same. In other words, if I literally just said, instead of Linux epoch time, if I just said timestamp 012345, does that make the problem easier to solve?
Well, it doesn't. I mean, to me, at that moment, yes. But now that I see it, it doesn't really make it doesn't really make it that much easier. We don't really care, exactly too much. It's just if they're both the same number.
I don't understand what you just said.
Yeah. Sorry. I was just rethinking what I was about to say. So yeah, we only care about like the same timestamps, as in if they're the same number. We don't really care. Like,
what is they exactly the same number? Clear up, calm down, start over. What is they the same number? I don't know.
So for the timestamps, we don't really care if we don't care about the actual value of the timestamp. We only care if that timestamp is identical to another timestamp.
Not even. That's totally incorrect. Think of it this way. Why don't I let's go to the basic naive solution, right? I know all I need to care about is the range of time between 1 year ago and now. Why don't I just take that chunk of sections, sort it by timestamp, and then just go through that and calculate the cumulative difference or cumulative amount?
Yeah, that was essentially what I did in the end, but
you should have done that at the beginning.
Yeah.
So, in other words, you know what to do. You just didn't do it. And I'm trying to figure out why. I think it's mostly because you're focused on the wrong things. The fact you panicked over the Linux epoch time and you kept going on that because you didn't know about it. When I would say take a step back, really identify what is important in the problem.
Okay.
That's why you fucked up this problem. You literally just focused on the wrong thing. And I think I've seen you do this over a few times before. It's that if you don't know everything, you just completely fall apart.
Yeah. That's yeah.
I'm saying you can't know everything. That's the part. That's the thing. I'm not gonna know what the epic time shit is. Like even for a job, I think it's system get time else or whatever. But I'm gonna literally say I know this is not the most important part of the problem.
Yeah.
So in other words, just take the chunk, like, just simplify the problem. I only care about time in the past year. All right, given that I'll invent this part and then I'll come back to it later if the person really wants me to. Like let's just in fact just say, hey, let's have the Linux epoch time in a fucking function, and I'll implement the function later. You know, it's like you're free to do that, as long as you come back to it if the interviewer wants you to. It's like hey, let's encapsulate this in a function, and then do it later. But given if I could come up with this, and I know that there's something that most likely exists for it, then we can make progress.
Yeah.
Like, let's think of it logically. Is there if you put someone else in there, and they did this problem, and they said, hey, it is most likely that there is some API given by the standard library that will give me the time. Would you agree or disagree?
Yeah, I would agree.
Okay,
Yeah.
so you can give them the benefit of the doubt. Let them solve the problem, and then we come back to it. Because us implementing that epoch time isn't going to affect the rest of the way the problem is solved.
Mm-hmm.
That's what I mean by the what is important and what is not. So you screwed up by not properly identifying that what I've said before is that it's how you solve the fucking problem, not the APIs, not the standard library knowledge.
Yeah.
So
Uh,
then remember what I said. I also said this before. You only make like one or two mistakes that completely derail your interview. That's true for anyone, and this is the mistake.
yeah.
So I mean, in this case, it's just literally just do what you've practiced, which is start with a naive example. Start with the solution that you know works.
Yeah. I mean, generally, I was in this moment. I was trying to think of the naive solution, but I guess, yeah, I zeroed in on the wrong thing when creating the naive solution.
So let's think about. Let's go back to that moment in time. What was preventing you from coming up with a naive solution? What was preventing you from coming up with a solution that works?
So, yeah, going back in that moment of time, thinking about my solution and how I came to it. Essentially, it was like, okay, now that we have to consider the timestamps, let's sort the timestamps and find the identical ones.
Why did identical come to your mind?
Identical because we need to find the busiest time in the mall, right? So we need to find the amount of visitors that exited and entered at a certain time period.
Okay, so you focused on that. So then, did you ask yourself why that might be wrong, or what can go wrong here?
What could go wrong was, okay.
Did you ask yourself that? No. First, did you ask yourself that question?
I think I did, but I didn't go too deep into it, unfortunately.
Okay, what was your answer? What was your answer to that question?
It was, okay, what happens if we have differing time periods? What do we do in that case?
Why is differing time periods relevant here?
Timestamps.
Huh?
I mean differing timestamps, not periods.
Okay, why is that relevant? Let me ask.
It's relevant because we need to find the timestamp at a particular. We need to find the timestamp that has the most visitors. So,
okay.
Essentially, having differing ones will allow us to keep track of like how many visitors we have at a certain time period, a time stamp, essentially. Keeping track of the differing ones.
Did what you just say make sense?
No. Keeping track of different timestamps allows us to actually find out which timestamp has the maximum amount of visitors. Essentially, it was my thought process.
But okay, but that didn't answer what can go wrong.
Yeah.
That just says, oh, I might have multiple. So let's take let's take what you just said at face value. The thing is that you assumed that your answer was correct, and you just said, oh, well, what can go wrong is if my answer gives me multiple timestamps that will give me multiple optimal points. That's not what can go wrong. That's assuming your approach is correct and just taking it to a logical, taking it to the next step. There's a difference.
Yeah, I should have thought of that beforehand. I only came after it after I was like going through some test cases to make sure I was right.
Remember the interview from Remember the one advice I gave him?
Don't talk for more than 15 seconds.
No.
At a time?
The one thing he kept bringing up over and over. The one thing that he said he completely burned into his fucking mind.
Keep bulletproofing your idea.
More specifically, cover your ass.
Yeah.
Did you cover your ass here?
No.
If you brought this actual problem, let's say like this was like something given to you at work, right? And
Yeah.
the level of sophistication, the level of thought that went into it, and you bet your career on it, would you be okay with it?
No.
Isn't that exactly what this interview is? You have one shot at making it. You're betting your career on this.
Yeah.
And you're just kind of being willy-nilly and assuming that you're right. That's the problem. It's just that you're not careful about that. You're not assuming why you might be wrong. Remember, let's go back to the very first idea I ever gave you, the proof by cases. I told you that if for every single scenario, your case and idea covers all these different cases, and these cases represent the full universe of all possible inputs, then you've covered your ass completely. Right? It's the exact same idea here. Instead of cases, just think about why your idea might be wrong and come up with a test case to prove it.
Yeah, I think I didn't have the forethought to think of additional test cases until I got to the actual testing part of my idea.
I mean, that's fine and all, but it's just that you could easily come up with it earlier. Just do a small small walkthrough example. Not even the test case, just walk through an example for the interview. And the interviewer will tell you, hey, you're right or wrong. You know?
Yeah. I mean, yeah, that's essentially that's what I did, but like, the interview was really silent, so I didn't really get that help, I guess. So I just kept on going with some more test cases. And then
here's the thing, it depends on what example you gave him, which can easily be misinterpreted.
Okay, yeah.
So in other words, I tell you how if you came up with, let's say, this example, right? Let's say 0. I don't know if you can see my screen or not. Like here, I'll share with you on Discord. Hold up. Can you see this?
Yeah.
Cool. So in other words, let's say these are all enter exit or something like that, right? So let's say timestamp 0, you have 10 visitors and you have enter, E as an enter, right? And then you have 0, and then you have 12 visitors, enter, right? And then you said 1, I don't know, 9, exit, right? And then let's say and just for the sake of argument, let's say this is 10, 10, 20, and 20 and 22, right? In other words, you would have basically just said this. I assume that this one actually does cover the situation you mentioned, right? And then if you walk step by step through it, through your example, then the interviewer would have probably stopped you here if you did something like this. But I suspect what you did was something more akin to like just this. I suspect that this is you did this. It was way too simple. It was way too easy to fuck it up, to misconstrue the what's it called, the idea. Yeah. I know I said to start simple, right, and to grow complex, but this part can introduce some confusion as well because, like you said, he thought you were talking one thing, you were talking another thing.
Okay, yeah.
So in other words, you must have lost I'm pretty sure you lost the interviewer somewhere. Did you feel like your explanation at any time was kind of muddled?
I mean, he was really silent for like the entire thing, so it's really hard to tell. He essentially just left me to my
You
own
should be
devices.
aware. You should be aware of whether or not you may or may not have interview. So think back to like the explanations you gave. Did they make sense?
I guess some of them didn't make sense, and then some of them did. I know when I was trying out, like giving out my idea, and then it was a little bit off, but then I gave an example of what I meant to do, so that I think that was a bit okay. I think probably when I was in the initial parts, when I was trying out my idea and testing everything, then my idea was a bit muddy for him.
Yeah. So in other words, you probably pissed him off at some point in the interview that you probably just kept talking so much that he just gave up on helping you.
Maybe, yeah.
Did you feel like you were like saying a lot of stuff and not getting a lot of progress?
In the initial parts, yeah, because
There we go.
when I was having the math wrong, I was like, okay, because I was like, okay, how did the output get this solution? Like, how did the test case get this idea? As I was working through the test case to make sure I have the right idea of what to do, and I was like, I was getting like a bit of the math wrong, so I was like, how'd they get this idea? And then I kept fiddling around with it,
Okay.
and then I guess that's where he got lost too.
Yeah, the interviewer got lost because you focused on the wrong thing. You pissed him off because you were doing the wrong thing, and he just kind of gave up when you were talking about this because he's just like, whatever, man. You literally lost the interviewer just from this one step, this Linux epoch time, and you saying, oh, I don't know what to do. Let me focus on it, fiddle around with it, and fuck around with it, and I have no idea what I'm doing. You like within the first 5 minutes of the interview, you died. I'm gonna tell you that.
Okay, yeah.
So in other words, this could have been avoided, one, by knowing what the fucking Linux epoch time is, and I'm very surprised you don't.
No, I know what it is. I just kept focusing on not knowing the API, I guess.
And in other words, that came across as I don't know what it is.
Yeah. Okay, yeah.
There you go. That's literally the thing that killed you here. The rest of this is just like, okay, well, and then once you did that, you overly focused on the time, and then you get your test case completely wrong. Your idea was completely wrong, and you presented the wrong way, and then the interviewer finally caught on to what you were doing at the end, and that's why you basically fucked up the interview. There's like several, I would say there's several avoidable points, not outside of, let's say, let me put myself in there, and let's say I fucked up on the last epoch time, right? I would the first way to do it is to come with a little bit more complete test case, and then let's say I had this idea, right? The same idea you did, right? Let's say I came with a sloppy example, right? I'm gonna ask myself, in what case am I wrong? I would first identify, hey, wait a minute, I never tested for exit, right?
Mm-hmm.
And so I would have put an exit in here, and so let me make sure like my algorithm works for an exit. I would have tried putting it in there, and then tried it in different places, and then the interviewer probably could have stopped me and said, hey, wait a minute, that's not right. And it said, oh, but I did this, and I did this, you know? I at time 0, I have 10, at time 10, I have 20, and therefore my answer is 20. Interviewer would have stopped me right there.
Okay.
So in other words, you could have saved yourself. I imagine that you didn't come up with that test case until like about 15-20 minutes into the interview.
Yeah, that would be pretty bad.
Yeah, and so, but the thing is that if I did this and let's say I still pissed off the interviewer and I just explained this one idea correctly, he would have just been, okay, yeah, this is fucking wrong. And so this was entirely avoidable as well if you just thought, okay, let me make sure my testing is complete. Let me try it under different scenarios. So
Yeah.
this just means try more examples. Make sure your idea is bulletproof before you commit to it and write the test cases. In a sense, you can see these examples as test cases even.
Yeah. For sure.
So, everything after that is pretty much like, I don't know. Yeah, you have the fundamental structure. It's just just one thing is there's always like one thing you need to bulletproof yourself against, and that one mistake. So.
Yeah.
All right. Enough of that. Anything else you want me to look at?
Nothing, not at the moment. I did a couple other questions. I got the brute force for one solution. I couldn't come up with the more optimal one. But I haven't made a delta for that yet because I just recently did it, and then we had this chat, so I haven't looked at it too much.
Okay. Okay.
But other than that, nothing too much.
Okay. I would say have a chat with M if you can, and if he's available about the bulletproof idea. But it is like, I don't know how to describe it. It's like, yeah, like remember how I kept saying detail oriented, detail oriented. This is literally where
Yeah.
not being detail oriented is killing you.
Yeah.
So it's like I would say have another chat with him, try to figure out like how he was able to figure things out. Because I mean, I can tell you what to do, but I can't. I can give you an argument, but I can't give you an understanding.
Okay, understanding. Yeah.
Yep. All right. So let's do a problem. Okay, let me pull up something.
Yeah, for sure.
Not this one. Not this one. I've already given you this problem. Fuck. Oh yeah, no, I can give you this one actually. I don't think I gave you this one before. Well, maybe I have, but it's probably been a while since you've seen it. So let me see. Yeah, it's probably. Yeah, I think I. Yeah, I don't think I've ever given you this problem actually. All right, cool. Perfect. Let me bust up the timer. Alright, cool. Here we go. So suppose I give you a block of text and a set of strings. I want you to find me the shortest number of words in the block of text that contains the set of strings. So what do I mean by this? Let's say in my first example, I have this string 1, 2, 3, 4, 5. And I have a set I'm looking for called 2 and 4, right? The shortest string here would be 2, 3, 4 in the middle, right? But in the second example, if I have 2, 1, 2, 3, 4, 5, and my set is 2 and 4, the shortest string is this 2, 3, 4 here. Does that make sense?
Yeah, that makes sense. Yeah.
Okay, cool.
Okay. So the 2, 3, 4. Yeah, that's 2 and 4. 2, 3, and 4. I want you to find the shortest that contains a set of strings 2, 4, and 5. Does it? Do they have to be like in the same order, the set? So if I had, I mean, does the set? Do I have to find it in sequential order? So let me give you an example of that. So let's say 5, 2, and 4. Can I have something like 1, 4, 3, 2, where I return something like this, and the answer would just be 1, 3, the indices of the string essentially.
Okay, so the thing is that I want you to find the shortest number of words in the block of text. Let's do this. Instead, I'm going to change this problem set to be, instead of shortest number of words, yeah, it's in the block of text 13 set, and I want you to return the actual string itself. Or actually...
Okay.
Yeah, return this.
Not...
Or index, it doesn't matter. Actually, return the index. Index or string itself, it doesn't really matter that much. But I understand what you're asking. You're asking if the order in the set matters and relates to the string itself. If this... Yeah, I'm going to say no. You can think of, even if, in this example, if the set had 4 and 2 in that order, I would still return the exact same answer. Does that make sense?
Okay, yeah, that makes sense, yeah. Okay, so... That's not too bad. I guess. 1432. I'm guessing you'll give me at least valid word. The set will contain at least valid words, right? I won't have an example where 1, 2, 3, and then the set is just 4 and 5.
You might get that. You might get that.
Okay, I might get that. Let me just do valid input. Okay.
It's a valid input, but you would just return an empty string.
Oh, okay, yeah. So output would just be empty. All right. That's okay. Yeah. Okay. So I want you to find me the shortest number of words in the block of text.
Okay. I mean, you could return the
Alright.
shortest length as well.
Yeah.
But I would say let's go with the yeah, actually let's go with the length.
I mean, yeah. I mean, that's fine. That's
It doesn't really
Generally-
matter. It's gonna end up being the same
Yeah.
thing anyway at the end of the day.
yeah. So okay. So let me go with the first test case first and go through an example. So set equal to 4. So 1, 2, 3, 4. The answer is 2, 3, and 4. So what happens if I know this won't work for the all of the test cases that I'll create, but just as a starting point, 3, 4. So I could get the first occurrence of 2. So that would first occurrence of 2 and the first occurrence of 4. So technically that'll be 1 and 3. But that won't work for the later solution. Well, the shortest 2. For this example, the last one, shouldn't it be just 2, 3, 4, 5, and the 2, 1 is excluded?
Correct. Yeah.
Like that?
Yeah.
Okay. Okay, so let me come up with my own test case then to make sure I'm okay.
Okay. So what exactly is your idea again?
So for the test case, I'm thinking of.
No. I mean your algorithm. You have a test case, but then do you have an algorithm or anything you wanna?
Oh, I mean the jumping start off board was get the first occurrence.
Oh.
Get first occurrence of strings in the set.
Okay, and then use those.
Yeah.
Okay.
And then now I'm thinking a test case that will make it not work. I
Yeah,
know it
the
won't
middle
work.
the
but...
middle one already does that for you, right?
Yeah. Oh, okay, yeah. Okay, good. Yeah, I didn't see that. Okay. So yeah. That won't work for sure because that would be 2. What happens if we always consider the most recent index then. So 0, 1, 2. I mean, what am I doing? Okay, so 0, 1, 2, 3, 4, 5.
Okay.
So if we get the most recent, we just saw underlining. Get the most recent occurrence of the number in the set. So if we get the most recent occurrence, it would be 2, 2, 3 would be 4 would be 4, and that would return us 2 and 4 for the set for the most recent occurrence. Yeah, so that would get us the answer for that one, but and for the first one too.
Okay, but does that even still work in all cases?
Yeah, I'm not too sure yet. Let me go for a new test case. Since we get the most recent occurrence, but what happens if we need to make sure? No, let me rethink this. Okay. So order doesn't matter. So what happens if I have 2? So let's go for 4, 1, 2, 4, and the set is equal to 2 and 4. So the most recent, I would go essentially be 4 equals to 0, and then I iterate for 2 equals to 2. So the shortest test case would be, the shortest answer, shortest string would be 4, 1, 2. But so far, but then once I reach 4, that'll be 0, 1, 2, 0, 1, 2, 3. The shortest string would then be 2, 4. So I guess it works in that sense. But how am I going to get the minimum and maximum of each word in our set? Like the most recent occurrence of each word in our set. If I iterate over it, I need to find the minimal and maximal indices of our sets. So that would be min equal 2. No, yeah, min equal. Well, here, let's go through the first example one more time, but with 3 words this time to make it a bit better. 3. 3. Yeah, 0, 1, shortest string. Take that away. Don't really care about that. 4 then become 3, then 3 would become 0, 1, 2, 3, 4.
Okay.
So yeah, and then shortest string would then become 2, 4, 3. If we iterate through our every number or string inside our dictionary, our key value pairings.
Mm-hmm.
So if we get minimum and maximum in indices of our key value pairing.
Okay.
And essentially our string will be the list minimum to maximum plus 1 shortest string.
Are you sure this
But
is
now
gonna
let's
work?
Huh?
Are you sure this is gonna work?
I'm gonna test it again just to be sure. So what happens if we have 4, 1? When the set doesn't really have any valid indices. Any valid words. So in this case, I would just do 1, 2, 3. Set would be equal to 4 and 5. So, I'll have the index for, the key value pairings for everything else. No, I wouldn't. No. Let me think about this a little bit more clearly. Yes, I should have the key value pairings for everything. So, 2, 1, 3, 2. And then I would iterate over my sets and find their most recent indices. But 4 and 5 don't really exist in there, so I could just set them to default value 0, essentially. Or just not return anything. We'll return a value that indicates it's an invalid value. So that would just return us an empty string, essentially. Okay. So far I've covered the case where invalid strings and sets. Yeah. To make this a little bit clearer, strings and set do not exist in, what do we call it? Block of text. Yeah, strings and set occur in block of text, but in different orders.
Okay.
Different ordering. what other test cases do we need to look at here? I think so far,
So you're gonna
we
only look
have,
at the minimum and maximum values that you see here, and that's your shortest string.
yeah, find the minimum and maximum indices of the key value pairing
Okay.
that we have that also exist in the sets.
Okay. Again, I can
Yeah.
see a very obvious way to come up with a test case that'll break your example or break your algorithm.
Okay. Let me see if I can think of that then.
It's
really
very
quickly.
simple, very easy to do.
Let me just go down here then. Let's try 2, 2. Set is equal to 2. The most recent occurrence, the output of that would just be 1, which is just 2. Because the minimum and maximum are the same thing. Occurs everything the same. What occurs a little bit differently then? 2, 4, 2. No.
Alright, for the sake of time, I'll give it to you.
Yeah. Okay.
And then let's say you're at 1 and 3. Does that break your answer?
So that breaks it a little bit. I just there's an easy modification to it. I should have explained a little bit earlier. But that is a good catch. Yeah. So I get when I iterate over. So how do I explain this? Give me a second. So for a brute force on.
Yeah, you still haven't given me a brute force solution, dude.
On every value update, so every key value update for a set, for a key that exists in the set, get the minimum and maximum of indices of the key value pairings in the sets. So that essentially fixes it, sort of. So, but it's pretty bad. So essentially, we go 1, 2, 3, 3, set equal 1, 3, and then we would have 1, 2, 3. 1, 0, 2, 1. So once we encounter 1, then we would get min and max indices, which is 0. But we just return that. Return 0. So that is which is equal to 1. 2, we don't really do anything. But 3, once we get 2, get min and max, which is 2 minus 0. And that returns us 1, 2, 3. And then once we do 3 again, get min and max, which is 3 minus 0, but not maximums. But not shortest, so we don't consider it. Yeah.
Are you sure your answer is correct?
For on every get the minimum and maximum indices of the key value pairings in our sets. Get the minimum. Record the shortest one in length. Right? I want you to find me the shortest string, yeah.
Okay.
Record the shortest one in length of words.
Is there a way I can just break your code like really, really easily?
Let me think of it again.
I believe me, I'm gonna be mad if I can just show it to you and it's gonna be very simple and you can't think of it.
I'm sorry, yeah. 3, 3. We know we covered the 3, 3 case, but what happens if we do 1, 1 set equal 1? We already covered this one, but 1, 0. That's 0. We cover 1. It's just any which one, whichever one occurs first, so it doesn't really matter. So it just returns the same result either way, which is 1. 1, 2, 3, 3. Let's check the previous test cases for an idea. 4, 1, 2, 4, 3. We see the set of that is 2, 4, 3. We see 4, 2, 4, 3 over there, yeah. 2, and then 4 is 3, and then 3 is 4. So that's the minimum. But we also need to make sure that all the values in the set are considered in our key value pairings. So yeah, so only when on every key value update that exists in the set and that length of set equals to the length of key value pairing dictionary.
So you think your answer's right?
I mean, let's make it one more time.
Okay, you know what? You're 20 minutes in. Let's put a
Yeah.
pause here, because this is
Yeah.
you are honestly like you are not gonna solve this problem
Okay.
ever. The way you are right now, you're never gonna solve this problem. But you know what? Yeah, I can get you run for another 20 minutes. If you think you're still on the right path.
No, it's okay. I'm not on the right path. You don't think I'm on the right path?
Nope. I can tell you, you're gonna fail this interview, and you've already failed it like 10 minutes ago, by the way.
Okay.
But you know what? I'm gonna make you suffer for it so you can feel the pain. Go for another 10 minutes.
Okay.
And I'm gonna tell you exactly why. I'm gonna tell you why.
Okay. You want me to find the shortest string in the block of text that contains a set of strings. The shortest text. So, going all the way to the most one to not ruin the space. For the most recent example, the latest page, so 1, 2, 3, 4, 5. Yeah, I mean, if we get the latest indices of 2, then that'll be 1.
For every key value pair of a key.
Right? And then once the length of that is equivalent to, no, that doesn't work too well either. Well, I mean, we don't really have to explicitly do the length check. We can just say for each element in set, if set in dict, which in this case means that just going through an example test case.
I'm gonna tell you, I have no idea what the fuck you're doing anymore.
No, I mean,
do you have any idea what the fuck you're doing?
Trying out explicitly typing out the test case that I'm trying to do.
Okay, your test. I'm talking about your idea. Do you have any idea what the fuck you're doing with your idea?
Currently my idea is I
see it right here. Why are you convinced this is right?
I mean, I'm not convinced. That's why I'm a little bit testing
So
it
in other
right
words,
now.
I just could you come up with a very simple, suboptimal, not efficient at all solution that works? That's what I'm first asking you.
Yeah. I mean,
And
yeah. I mean, okay. This was my idea
So
of.
that's your idea.
Yeah.
This
So
is your
let me
suboptimal
try.
solution.
Huh?
Is this your suboptimal solution?
Yeah, me trying to come up with the suboptimal. Yeah.
All right, I'm pulling the plug here.
Okay.
I'm pulling the fucking plug, and I'm gonna tell you why I'm like right now. I'm pretty fucking mad. Do you know why?
n- Uh. I'm. I probably zeroed in on the wrong thing.
More specifically,
Um. 2-1. I'm not covering my ass.
no, you are. You're trying
Okay.
random test cases, but you have a more fundamental problem. That's why I'm mad. I don't care about that. I care about this problem, this fundamental problem.
Um. The minimum. No. I'm not being too clear with. I'm not. I think I'm losing you.
There's a more fundamental problem.
Not clear enough in explaining my ideas.
No, your idea is trash because you are coming up with a magic bullet solution at the very beginning, not a naive, simple solution. And everything you're doing for the past 20 minutes has been because of that. Let me paste my notes, and I'm going to tell you very specifically, is that when you basically came up with a, okay, why are you saying, oh, it has to be the first element, it has to be the last element of the list? I'm telling you, that's way too complicated already. It might be simple to you, but it's very complicated. Because look at how much you've had to, like, patch and pray, then you couldn't come up with a good test case against it. You couldn't prove or disprove it easily. And that's how you, I think this is one of the things we talked about in the very, very first session. Make sure your ideas are simple. Even, let me tell you, like, the most super simple way of doing this one, try every single possible substring in the fucking string and just see if it contains 2 and 4. And if it does, record the shortest length.
Yeah.
Now, why the fuck didn't you come up with that one?
Yeah, it's a good point. I don't know why I didn't come up with that one. I think I zeroed. Yeah, I thought initially I latched on to an index method of solving it instead of going through the brute force way.
I mean, I've never told you to do like, oh yeah, try the complicated idea first. I've always told you, give me the brute force, naive solution that works. And I've always told you to start off with the naive solution. Start off with the naive solution. And this is a great example of you throwing that all the fuck away. That's why I'm mad. It's like, who the fuck taught you to do that? Who the fuck taught you to zero in on some complicated ass bullshit and then try to iterate over that complicated bullshit when it's incomplete? I certainly didn't.
Yeah.
Like, that's it. So, next thing. Obviously saying something that works, and you're still trying to, like, to me, like, when you kept coming up with these test cases, the thing is that it was so obvious that it didn't work, and you still felt the need to have to write it out. You could have just easily been more efficient and said, hey, this doesn't work. And you didn't have to write out a test case in order to prove that it didn't work. So, and even then, the way to test these, it was so easy. So for instance, this one, right? You say the shortest string is the what's called the minimum index and the maximum index, right?
Yeah.
Well, not only did you not prove that, all it took was one insertion for me to disprove it. It's the same thing on the top one too. All I do is just insert one little thing in order to break it. And the easiest way to test your example is really, what does your idea rely on? In this case, you think the idea relies on that it must always be the smallest string and the largest index, right? It must always be the earliest index and the latest index. That's what your idea is saying, right? And but then it's just like, can you come up with an example where that is not the case? where it is not the first index and the last index. And I literally just did it by repeating the last index.
Yeah, I mean, my idea was getting the most recent occurrences of the string of the getting the most recent occurrences of the string. So in that case, it would get us our minimum. If we do get the minimum and maximum indices, it would be the minimum and maximum of the most recent occurrences. So I think that would get us a shorter string.
Okay, but you overfitted that to your example, right? You just said, oh, it's because of these examples that I have that I'm going to just keep doubling down on it. And then you kept doubling down on it to say, oh, let me patch and pray, let me patch and pray, let me try this other little tweak, let me try this tweak. And when you go down that route, it's like, well, you're building out a foundation of sand. Remember, and it all goes back to you coming up with this idea of indexes. And yeah, that's going to be part of the optimal solution, but you never once came up with a simple, naive solution that actually works. Iterating is fine if you get in a few instances. One, if your initial idea covers 90% of the test cases, like you know for sure 90% of it, and all that's left is like the last few 10% that you can throw like a null check with or a proof by cases with, with like if state 1, state 2, state 3, state 4, state 5, state 6. When the path forward is just like it's when that idea is rock solid. But the fact is that the index idea is not rock solid, and you haven't proven it either. It's not obvious that doing it by this minimum maximum index is ever going to work. In fact, it's not even obvious which indexes you should take on an absolute basis. So I don't know where this index comes from. There's no link. There's no proof that this works. And you kept doubling down on it. So I don't know, I don't know why. Let's focus on why you decided you focus on the indexes.
Because what I focus on the index because it said the shortest string in the block of text.
Okay.
So to keep track of which words occur in the set, I would keep track of the indices. Let me rephrase that. To keep track of the strings that occur in set, I would keep track of the indices inside the block of text.
Can I find the shortest string without recording those indexes?
You can record the length.
That's fine, right?
Yeah. But to get the length, I would need the indices, so that's why I thought of getting the indices.
Maybe at some point you might need the indices, but then that's going to be the implementation of the code, right?
Yeah.
So in other words, you went straight to the implementation without thinking about the idea first. I mean, eventually you're gonna need the indexes. Like, even if you do like 2 for loops, right? So if like the simplest idea is like I have my starting index at 1, and then I try 1 2 1 2 3 1 2 3 1 2 3 4 1 2 3 5, right? And then I start at 2 2 3 2 4 2 3 4 2 3 5, right? And just keep going. Just do that over 2 loops, and I would have solved the problem. So the indexes does apply. It's just that they're an implementation. They're a way to service the idea. And you made that the cornerstone because you thought, oh, indexes are going to be the centerpiece of the idea instead. Well, 1, you never proved it, and 2, you doubled down on it when it wasn't proven. Yeah, indexes are going to be useful. It's just like, why not just come with a very simple brain-dead solution? And that 2 loops uses 2 indices, right?
Yeah.
So this is where like the details, every single detail, every single misstep, every single inefficiency that you've ever made. This is where like all that is like you can't see that. This is where it's biting you right now. Right now is where all the things that you've kind of ignored, been a little bit sloppy about, and now it's all biting you in this moment.
Yeah.
All right. The rest of the notes I have in here are going to be pretty much all that. It's literally just saying why not just use all the examples I gave you. You were obviously stating something that doesn't work, and you actually still felt the need to write it out to disprove it. You could have easily done a mental test for it, and because like I even gave you an example of it not working. I
Yeah.
think it was the one where I said, "Hey, why not just try the second example I gave you?" So and you
Yeah,
felt the
yeah,
need,
yeah.
and you felt the need to come up with another example. It's just like, why not just? I gave you some examples. Why not just use them? You know?
No, I did use it, and then
No,
I
because I
wanted.
told you to use it.
Yeah,
So why not
I didn't
just
see
you?
that.
Why don't you have? It's like it's a free lunch, right? Why not just take the free lunch? I have a free tool to check if my answer works.
Yeah,
Why
I
do I
should
need
have
to come
used
up with
all.
something new? It's like why it's like
all
I'm inefficient here, you know?
yeah.
So this one
I
was
mean, should for creating the test cases, what happens if the ones are a little bit too complex in the test cases, though? Should I
that's fine.
still
Come up with something simpler.
test? But for creating the base cases, should I go through all the example ones that they give first, if even if they're a little bit too complex, or go find myself a really basic one first then?
The really basic one's gonna be fine, and you can come up with it
Yeah.
yourself if the examples that they give you are complex. But I would say that you should have come up with it very, very quickly. The base cases are
Okay.
super easy to do, right? It's just like 1, 2, 3, and then maybe like some duplicate strings, right? And then like here and there, and then after that, well, I've tried all the easy ones. Let me try all the medium ones that the person is giving me.
Yeah.
It's like there's an order to it, right? Let me solve the easy shit before I solve the hard shit. And it's like over optimizing solution. Why not start with a bulletproof one? Already addressed this. Yeah, again, the easiest way to bulletproof it, to test your idea is to understand what is the fact that your code relies on. I've already addressed that here with the minimum maximum. You assumed that the indexes, the minimum maximum index that you'll ever encounter is going to give you the right answer, which is obviously wrong if you just thought for 2-3 seconds. And I put it. I mean, even as I say that, it probably would have been obvious to you. And then you're still and then when you find yourself being very complicated, overly inventing stuff, and keep patching and doubling down on things that don't work, maybe you shouldn't double down on things that don't work, right?
Yeah.
There's no such thing as magic bullets. There's only logic. And really, the what I taught you at the very beginning, start with a simple naive solution, grow it. And because there's always like some super stupid, like billion-year runtime idea that'll work. You could probably write Google in theory with like a bunch of loops, right? 2, 3, 4 loops, or n number of loops. It's just that it's going to be super, super, very, very long and complicated, right? And then, of
Yeah.
course, everything up from there is just like building of that and optimization of that.
Mm-hmm.
So, all right, everything else, maximum indexes. I assume that why is this true at all? Again, you trying random fucking shit. You patching and praying. All right. Yeah. All right. So I don't need to repeat myself. You know what you did wrong here, and it's like, yeah, don't ever make me tell you that again.
Sorry. Yeah.
All right, I'm gonna go get a fucking White Claw. All right. Next problem. And
Okay.
don't make me give you that talk again.
Yeah. Yeah. Okay.
All right. Given a red tape, a set of blue tapes. You know this one?
You gave it to me previously. This
All right.
one.
So if you know the answer, that's fine. Okay. Let me try something else. this one. Okay, the minimum number in valid parentheses in order to make the string valid. That might
Maybe
be that might be a little bit easy. Yeah. All right, let's see how clean your approach is on this one, actually.
okay.
Okay, let's see. All right, suppose I want you to remove the minimum number of invalid parentheses in order to make the string input valid. So what do I mean? And I want you to return all the possible results. So in other words, the input string may contain letters other than the parentheses, open mark and close mark, right? So what does this mean? So let's say I gave you this string: open, close, close, open, close, right? Well, there's two ways I can do the deletion. I can do like a minimum number of deletions, which in this case is 1. I can either delete one of the additional close braces here, or I can actually keep an open, or I can delete the this close brace as well. Does that make sense?
So I can either remove the end, this closing bracket, or this closing bracket. I mean opening bracket. Oh, that closing bracket.
Yeah, this one. Does that make sense?
Let me go through it one more time. So we can remove this closing bracket, like the one I'm highlighting, to make it a valid input string, or remove what other ones can you remove? This. Yeah, okay, yeah, I get it. No, well, wouldn't they just give us the same input string? Doesn't matter which one we really close.
In theory, it doesn't really matter which one you remove. It could be like multiple duplicates. It doesn't matter if you remove, like, let's say this one versus this one. It will get you the same result.
Yeah.
So, but you notice there's no duplicates in the output.
Yeah. But I was wondering how they would get to that then.
So what happens if I delete this? Like I just said.
Yeah.
Does that work?
Which one? Oh yeah, that one. I see. Yeah. If you delete that one, that works. Yeah. So that's just the one. Yeah. Okay. Yeah. No, I get it. Yeah. So let me make this a little bit. So that's the string. We can either remove this one or this one.
Yeah.
And if we remove that one. Wait, if we remove, so let me try to go through. So if we move that one, then it gets. Okay, yeah, I get it. Okay, yeah, I get it. For the examples. Okay, so I guess I can start with this. The base one without any letters first. So once we find one solution I'm thinking of is we can just find the. So this is just like a really high level solution that I'm not too sure if it works just yet. So find the minimum number and the minimum number of invalid parentheses in order to make the input string valid. Once we do that, then we remove all possible. How do I go in this? I'm trying to say. Let me rethink this. How I can word it. Okay, yeah. Remove that same minimum number of parentheses at every possible point in the input string and get all valid results.
Okay.
So first, what I'm thinking of is instead of finding the minimum number of valid parentheses, so I would essentially, to find the minimum number of invalid parentheses in order to make the string valid, I maybe can have a check for checking if input string is valid.
Okay.
That's one check. That's
Right.
one part of the solution. We check if the input string is valid. Well, check if the given string is valid. Because then I'm going to be passing in multiple strings to that. So check if given string is valid, and then
I want to stop you here. Do you think you're making a mistake that we have talked about in the past?
I mean, okay. Let's think of a more simplified solution.
No, I'm asking you. I'm asking you.
Yeah.
Yes or no? And what is it?
So far, I'm just browsing ideas that I'm not too sure about.
Okay.
I think it's a little bit too early, I guess, or...
Are you sure? Okay.
Yeah.
You know what? I'm going to let you run with this for another 10 minutes, but I guarantee you're going to screw up. Go ahead. And I'll tell you why, because I remember this moment right now. Remember what you have written on screen right now.
Okay.
All right? And I'm going to tell you why you screwed up. But go ahead. Go. And I hope you prove me wrong.
So... we basically iterate through our entire string. So
Okay.
remove parentheses. So let's write this a little bit easier. So for each character in parentheses, remove it. Remove the character. Check if rest of the string is valid.
Okay.
And so that will only be valid when we have to remove one parentheses. So what happens if we? So yeah, that's only what happens if we remove one parentheses. So how can we expand this into removing k parentheses, as in every single parentheses that we have? So we can define for each char in parentheses, remove the current char, check if the rest of the string is valid. We need to generalize this to k parentheses. So what happens if we generate? We can always initially, if we generate all permutations, all permutations wouldn't really work of a string. I don't know. That's a dead end. If we generate, yeah. So the problem is generalizing to remove k parentheses. How do we? Yeah. I'm getting an idea if opening equals closing, but we should really scrap that for now because that's a little bit too much of an optimization so far. but it might be something to keep in mind for the future. Are there any ideas we can explore for this? Any more brute force solutions that might make more sense? So we have minimum number. How about this? If we just try it with a simple test case of just this, a valid one. So remove the number, parentheses, the number is 0. Don't really remove anything. Over here is 1, we need to remove. And then that is equal to 2. We need to remove 2 parentheses for that to work. So how can we remove the parentheses? So what we can do is try all possibilities of, in this case, a recursive function. So if I give them the string and the number of left and right parentheses, at the moment left and right don't equal. No, that wouldn't work too well. Left and right don't equal, because what happens if we have this, just this, then that wouldn't work out too well. Scrap that. Parentheses in regards to splitting up. So in a recursive function, we could try to find a magic function that we will implement the functionality later. So if we're given, in a recursive function, we can call another function and we'll define that implementation later. So if we're given a string, no, that's essentially what I did before. In this.
What's the thing I told you? Do not make me tell you. Don't make me repeat this statement, please.
I'm sorry. Let me.
No, don't apologize to me. Apologize to yourself. Apologize to your future self who you're gonna let down. Not me.
Yeah. I'm just. Yeah. 2, 4. Okay. I mean, I'm thinking of a brute force solution.
Simple, naive, brute force.
Yeah, simple, naive, brute force. This generally, like this one was my brute force for 1 parentheses.
Okay.
I just need to figure out if I can utilize that to make k parentheses. Remove k parentheses because we need to remove the minimum number.
Okay.
So how can I was either trying to expand that to k or come up with a new solution. A totally new brute force that might work off the bat with just k. K removal parentheses. So if we remove the minimum number of valid, return all possible. So if we okay, I think I have an idea. So we can define it a really brute force way is, so for each we get the length of the input string, right? And then for each number in the length of the input string, remove this number of parentheses from the input string.
Okay.
And then after we check if the rest of the string is valid.
Okay.
Check if the rest of the string is valid. And then, as soon as we find the earliest string,
Sure.
like the earliest number that we encounter that the string is valid. So, first occurrence that this is true. So once we encounter the first occurrence that this is true, since we're iterating from 0 all the way to the length, the first number we find will be the minimum number of invalid parentheses. So this will be first number in count here to make this condition true will be the minimum parentheses
Okay, sure.
to remove.
Okay.
Yeah.
So how would you do if you remove this number of parentheses from the input string?
Yeah. So to go into that further, if we had to remove a certain number of parentheses from the input string, we would try all possibilities. So try all possibilities. That would be either.
Well, how would you do that? Because you already said.
Let me say that. So basically, at each step, we either remove this parentheses or take this parentheses, and we do that k times. Repeat above step k times.
Okay.
Yeah, at each step, remove this and proceed to rest of the string. Yeah.
Okay.
Proceed to the rest of the string. So as in recurse on the rest of the string.
Mm-hmm.
So let me make this a little bit simpler with the test case. Explain this a little bit simpler with the test case. So if we have this test case, so the length is equal to 3. So for the first case 0, let's see, this is 0. If we remove 0 indices, parentheses from the input string, we don't really care about that anymore. It's 0, base case, don't remove anything. And now once it's 1, we go from each step. So it would then be, okay, let's see if we have a branch for taking the current parentheses. So it would be that, and then another branch for not taking the current parentheses. So if we go into that, it would be then this, or so then the branches that would spur from that will essentially be this, that, taking the current parentheses that we have, going through that. So I'm going to just this branch, the opening bracket branch. So we would have opening and closing for that. We would, so we'd have either opening or closing for that, or just keep the same. Keep the same. And then we would do it again with over here and over here. Yeah, that would be that branch of cursive. So we would just remove one at every possible spot. And for this one, it would essentially be this, and this, and this. Yeah, so it would be take. So essentially, it'd be like that.
Okay.
For the branch-wise. Because at first, we take the current index, we take the current closing bracket, then we could move on to the... And we move on to the two test cases where we either skip the current bracket or added the next current bracket to it, the closing bracket to it. So yeah, that would be removing 1. And 2 generally will be the same thing. 2. So we're allowed 2 removals. So I guess that okay. You either remove this parentheses or take this parentheses. So that only works for 1 removal. Currently, how can we expand this to 2? I mean, we can have a if k removals. Maybe if k for each number k, if number of removals equals k